Chip war is a history of the semiconductor industry from its origins to the present day. It is a book about technology that contributes to our understanding of the dynamics of imperialism and global political economy, even if Miller himself would not think about it in those terms. Most experts see the move as China's most significant retaliation against the West semiconductor tech blockage, which expanded dramatically last October when the US limited the export to China of the most cutting edge chips and the equipment capable of making them. Chip shortages result from a mismatch between supply and demand that cannot be addressed quickly either by chip manufacturers, by scaling up production, or by markets by adapting to the chip production profile. The challenge of resolving the two is not going away and may even grow in size. Is the semiconductor crisis finally over? Some chip shortages could remain through 2023 and into 2024. Though supply of semiconductors and raw materials will generally improve in the auto sector. The auto sector can expect a strong year in 2023 with global car production up 3%. Who is the biggest semiconductor? Taiwan Semiconductor Manufacturing Company Limited, founded by Maurice Chung, is known as the world's largest semiconductor company, mainly engaged in the best foundry service for the global logic IC industry. Why does not the US build chips? It's also difficult and expensive to build new facilities to manufacture the vital silicon component, which means companies have to rely on existing plants. A new semiconductor factory can cost up to 20 billion. The US Department of Commerce is set to prevent the sale of some advanced artificial intelligence chip to China over concerns that they could be used for military development purposes. This will restrict the export of chip makers NVIDIA, A800 and H800 chips. An increase in remote work and remote learning caused a surge in demand for computers, network peripherals, and other consumer electronics with chips. Due to lockdowns, chip production facilities were shut down, leading to the depletion of inventories. We rarely think about chips, yet they have created the modern world. The fate of nations has turned on their ability to harness computing power. Chip War, the fight for the world's most critical technology, is a 2022 non-fiction book written by Chris Miller, an economic historian. It tells about the transformation of the semiconductor into an essential component of contemporary life, narrating how the United States gained supremacy in chip development and production and incorporated this technology into its military system. This book contends that semiconductors have defined the world we live in, determining the shape of international politics, the structure of the world economy, and the balance of military power. A next generation chip emerged roughly once every 2 years, requiring new facilities and new machinery. Strategists in Beijing and Washington now realize that all advanced tech, from machine learning to missile systems, from automated vehicles to armed drones, requires cutting edge chips, known more formally as semiconductors or integrated circuits. A tiny number of companies control their production. Globalization as we know it would not exist without the trade in semiconductors. You may be surprised to learn that microchips are the new oil, the scarce resource on which the modern world depends. America's victory in the Cold War and its global military dominance stems from its ability to harness computing power more effectively than any other power. Until recently, China has been catching up, aligning its chip building ambitions with military modernization. Globalization as we know it would not exist without the trade in semiconductors. This book portrays the history of chips, the origin of chip manufacturing and its science, provides a fascinating story and makes sense to those who are relatively ignorant about the technological and engineering aspects. The US policymakers are keen to regenerate its tech prowess by ensuring that chip production is again restored to the US. A section of US policymakers argues that the best way to contend with China in the economic war is to focus on what the US does best, encourage innovation, and attract the best talent worldwide. The US government introduced chip sections aimed at hobbling China's ability to develop advanced artificial intelligence. But those sections had loopholes that allowed Chinese firms to keep buying and building chips used to train some of the world's most advanced AI algorithms. The new restrictions announced by Commerce Department also impose new rules for reporting the sales of other types of advanced chips, new controls on sales of advanced chip making equipment and design software, and to prevent Chinese companies from obtaining chips through foreign subsidiaries. Chinese tech companies, including ByteDance, which owns TikTok, Baidu, Alibaba, and Tencent, have reportedly placed 5 billion worth of orders for H800 chips in recent months. US chip restrictions may have helped boost China's domestic chip industry, which is thought to lag behind that of the US, Taiwan, and South Korea by many years. The US government kick-started the industry. Military and space applications represented over 95% of the chips. Fairchild Semiconductor, an industry pioneer, produced in 1965. Today, the US government represents only about 2% of the chip market and outsources production of even the semiconductors used in military and spy applications. A new chip making plant can cost 20 billion to set up. A copycat approach failed. The USSR's Cold War semiconductor strategy was to spy on and reverse engineer to the production of the US chip sector. Analysts found that Soviet copies of Intel and Motorola chips were always half a decade behind. Semiconductor manufacturing has been a shockingly male industry. Chip making sector from its origin includes almost no women. Low interest rates and easy loans were a key competitive advantage. Japanese companies rose to leading positions in the industry partly because they had access to much lower interest rate loans in the 1970s and 1980s than US chip makers to finance the massive investments to build semiconductor factories. Intel is a tragic case study in missed opportunities. CEO Paul turned down the contract to build chips for the iPhone because Intel overestimated what it would cost to make those chips and vastly underestimated the volume it would sell. Intel instead prioritized the production of server and PC chips with high profit margins, which made it impossible to try anything new. Those who saw a step ahead in the industry often succeeded enormously. TSMC founder Maurice Chang foresaw the opportunity for a semiconductor manufacturer that made chips designed by its customer at a time when chip makers mostly designed their chips in-house. Outsourcing to companies abroad paradoxically made US semiconductor dominance possible. Qualcomm, a leader in chips used in smartphones, for example, designs semiconductors that are then manufactured by companies like Samsung and TSMC. Companies like Qualcomm might not have survived if they would had to invest billions of dollars each year building factories. Only two companies are now capable of the most advanced semiconductor manufacturing. They are Samsung in South Korea and TSMC in Taiwan. TSMC has a massive 55% share of the market for manufacturing chips designed by other companies, with Apple as its biggest customer. More than one third of the new computing power in the world relies on each year is made in Taiwan. China remains highly dependent on the US for chips. All of China's most important technology rests on a fragile foundation of imported silicon. Chinese firms have just a 6% share of the entire chip supply chain compared to 39% of the US, 16% for South Korea, and 12% for Taiwan. You can find chips in cars, dishwashers, microwaves, coffee makers, and your smartphones. Chips are in almost every device that has an on and off switch today. It's a piece of silicon the size of a fingernail that has carved into its millions or billions of tiny circuits. The number of chips we rely on in our daily life is growing every single year. There is not a single semiconductor facility in the world able to self sufficiently produce chips. Right now, the US is trying to cut off China's ability to make advanced semiconductors on the judgment that advanced semiconductors are critical to training AI systems. If you can't get access to the most advanced chips, then you can't make meaningful advances in AI. To make an advanced semiconductor, you need to buy machine tools from just a handful of companies around the world that have the precision capabilities to manufacture these tools. One of the most important of these companies is a firm called ASML, which is based in the Netherlands. It has unique capabilities which no one else in the world can replicate to produce a type of machine called an EUV lithography tool, without which making an advanced chip is simply impossible. Most people don't realize that chip making is that central to the economy of Netherlands. How did it end up that a Dutch company owned this piece of critical chip making technology? Globalization, as we know, it would not exist without the trade in semiconductors. Around a quarter of the chip industry's revenue comes from phones. Much of the price of a new phone pays for the semiconductor inside. For the past decade, each generation of iPhone has been powered by one of the world's most advanced processor chips. In total, it takes over a dozen semiconductors to make a smartphone work, with different chips managing the battery, Bluetooth, Wi-Fi, cellular network connections, audio, the camera, and more. Apple makes precisely none of these chips. It buys most of the shelf. Memory chips from Japan, radio frequency chips from California's Skyworks, audio chips from Circus Logic based in Austin, Texas. This book provides a remarkable history of the computing world and the shrinking of the transistors into even smaller, even tinier chips. This book helps us understand how global this computer chip world is. This book shows us the vast, gigantic challenge facing any country which wants to do all of it needed chip building within its own country. It may not be possible. China now spends more money each year importing chips than it is spent on oil. China is devoting its best minds and billions of dollars to developing its own semiconductor technology in a bid to free itself from America's chip choke. If Beijing succeeds, it will remake the global economy and reset the balance of military power. World War II was decided by steel and aluminium and followed shortly after the Cold War, which was defined by atomic weapons. The rivalry between the United States and China may well be determined by computing power. Last year, the chip industry produced more transistors than the combined quantity of all goods produced by all other companies in all other industries in all human history. Nothing else comes close. In 1970, Intel unveiled a memory chip that could remember 1024 pieces of information, bits. It cost around $20, roughly 2 cents per bit. Today, $20 can buy a thumb drive that can remember well over a billion bits. Chips from Taiwan provide 37% of the world's new computing power each year. Two Korean companies produce 44% of the world's memory chips. The Dutch company ASML builds 100% of the world's extreme ultraviolet lithography machines, without which cutting-edge chips are simply impossible to make. OPEC's 40% share of world oil production looks unimpressive by comparison. Simply stealing a chip did not explain how it was made, just as stealing a cake cannot explain how it was baked. The recipe for chips was already extraordinarily complicated. Big tech firms Google, Amazon, Microsoft, Apple, Facebook, Alibaba, and others are now pouring money into designing their own chips. There is clearly no deficit of innovation. Yesterday's chips are so far behind today's chips. Tomorrow's chips will make today's chips seem ancient and quaint. It takes big money. Thus, government has been crucial and maybe more crucial in chip development. The chips are primarily made in only a handful of countries, especially the United States, South Korea, Japan, and Taiwan. And the most important chips are made in one place, Taiwan. Why copying and stealing does not really work in chip? It is not possible to copy all the details of how to actually mass produce these chips. By the time you successfully copy, it is almost out of date. Regarding Taiwan, Apple most advanced processors, which the world's most advanced semiconductors, can only be produced by a single company in a single building, the most expensive factory in human history. Fabricating semiconductors has been the greatest engineering challenge of our time. Apple sold over 100 million iPhone 12s, each powered by an A14 processor chip with 11.8 billion tiny transistors carved into its silicon. From Silicon Valley to the rest of the world, today's semiconductor supply chain requires components from many cities and countries. But almost every chip made still has a Silicon Valley connection. A typical chip might be designed with blueprints from the Japanese-owned UK-based company called ARM by a team of engineers in California and Israel, usually design software from the United States. Politics still matters for chips. For America, Taiwan is an indispensable partner. China, of course, also has strong opinions about the future of Taiwan. For now, it relies on TSMC as much as everyone else. It would be in everyone's economic interest to maintain the status quo. Yet, as recent events in Ukraine have shown, people don't always act in their economic interest. This book shows in scary detail that an invasion or even a blockade of Taiwan could send the global economy off a cliff. Beijing is seeking to build up design and manufacturing capabilities, and Washington hoping to slow China's progress. China, which spends more on chips than any other product, is pouring billions into a chip building Manhattan project to catch up to the US. China's spend more money importing chips than buying oil, and they are China's greatest external vulnerability as they are fundamentally reliant on foreign chips. The Biden effort to stop Chinese technological ambition built on the 2022 CHIPS and Science Act. It allotted subsidies to chip manufacturers to build operation in the United States, and at the same instituted the bans on the sale of advanced semiconductors and chip making technologies to China. Its biggest success arrived soon after the legislation passed when the White House convinced Japan and the Netherlands to comply with its provisions. Especially significant was the agreement by the Netherlands-based ASML holding company to stop sales to China of its most advanced extreme ultraviolet lithography machines for the manufacture of semiconductors. At the time of agreement, ASML's leadership insisted that the ban would only encourage the Chinese to develop like equipment for themselves, and that it was only a matter of time before that day would arrive. Now, even sooner than ASML's management expected, China seems to have done just that. According to the Beijing-based publication Security Daily, the Shanghai-based Microelectronics Equipment Group has developed a lithography machine capable of producing transistors comparable to those produced by the ASML equipment and needed for advanced smartphones, computers, and cutting-edge weapons. The issue was always a matter of size. The smaller the transistors a machine can make, the more it can fit on a chip. It was thought that China could not make transistors smaller than 7 nanometer, the scale used to measure their size. Now it seems this research effort has broken that barrier and is now verging on even smaller transistors of 5 nanometers. Two unanswered questions now remain. First is how the new Chinese machine compares to existing equipment in the United States, Japan, and the Netherlands. The second question is how fast the Chinese can leverage this breakthrough to accelerate the development of advanced chips. If the answers to these two questions include a lot of caveats and delays, then China's breakthrough will wait until it can make a difference in the Sino American chip war. If the answers are less troubled, then China will have clearly won this round, and the competition with the United States will move on to other matters. If much remains unresolved, China's quick response to Washington's ban offers at least one important lesson to economic and diplomatic strategy. Any ban such as Washington arranged in 2022 seldom can have any lasting effect, especially when, as in the case of the Chips and Science Act, they aim to stop the spread of technology. ASML's management now looks striking precision with its warning about what China would do.